Hello, friends. Welcome to Boyoun's live stream. I'm Cassio, and I'm very happy to be here with all of you. Today, I will take you on a journey to explore some of our remarkable delivery cases in Bangladesh as a bridge formwork manufacturer. We'll also give you a detailed introduction to our high-quality formwork products. Before we divide into introducing the Bangladesh project, let me provide an overview of our company. Our company, Shandong Boyoun Heavy Industries Company Limited, was founded in 2006 and focuses on the R&D, fabrication, marketing, on-site technical services of steel formwork for bridge, viaduct, tunnel engineering. The headquarters and the main factory are located in the Binzhou city of Shandong, China, with international department located in Beijing. The annual output is more than 75,000 tons. Boyoun has been qualified by ISO QM system. Since its foundation, more than 30 patents have been approved each year. Boyoun has served over 1,200 infrastructure projects, mainly for high-speed rail, expressway, railway, highway, and other large-scale infrastructure projects with experience forward solutions. Cooperated with giant state-owned enterprises and the well-known overseas construction groups. Our company Boyoun has served over 1,200 infrastructure projects, mainly for high-speed rail, expression, and so on. Over the years, we have gained extensive experience and expertise and built a strong reputation in the industry. We are dedicated to providing our customers with high-quality products, and more importantly, with excellent service and technological innovation. In the upcoming broadcast, we will go into detail about our previous complete projects, such as Panama Bridge, Airport BRT project, three bridges project in the Bangladesh, and answer any questions you may have. We hope that this live broadcast will provide you with more information about the bridges. And if you have any related project, you can refer to it. First, let's focus on Padma Bridge in Bangladesh. Boyoun participated in the construction. Bangladesh is a river-rich country, and the Padma River is one of the major rivers that traverse the country. The solution part of the Bangladesh, which is rich in natural resources and has a large reputation, face difficulties in transporting goods and the people to the northern and the central regions. The existing ferry services were time-consuming, weather-dependent, and could not meet the growing demand for transportation, which became a bottleneck for the overall economic growth of the country. Therefore, constructing the Padma Bridge became an urgent need to boost regional integration, enhance trade, and improve the living standard of the people. Before the Padma Bridge was built, in terms of transportation, there was only one highway bridge and one railway bridge upstream of the Padma River. A bridge had never been built downstream. People in the south and east could only rely on ferries to cross the river. Unduly, it took over 2 hours to cross from one side of the river to the other by ferry. In the rainy season from July to August every year, the cross time would take at least 7 or 8 hours or more. Moreover, ferries were very dangerous when sailing in bad weather, and the problems such as lost luggage often occurred. For residents on both sides of the Panama River, daily activities such as traveling, work, going to school, and seeking medical treatment were greatly affected by the difficulty of crossing the river, making life extremely inconvenient. For example, Residents live on the south bank of the bridge might need to spend 2 days to return to their hometowns. There were also relatively few employment opportunities, affecting the income level and the quality of life of residents. But after the construction on June 25, 2022, the Panama Bridge was officially opened to traffic, ending the long history of residents on the opposite bank of Dhaka relying on ferries. The crossing time, which originally took several hours, was shortened to about only 10 minutes, greatly facilitating the travel of residents on both sides of the river. At the same time, the bridge has also become an important transportation hub connecting Dhaka and the 21 regions in southern Bangladesh, improving the regional transportation solution. The completion of the bridge has upgraded transportation and accelerated commodity circulation, directly driving the development of the national economy. According to circulation by relevant departments of the country, after Padma Bridge is completed, it will bring an annual GDP growth of 1.5% to this project, benefiting more than 80 million people. At the same time, it has brought the export of Bangladesh. Some local products have been sent to the port of Hadia in southern India. It has also promoted the commercial development of areas around the bridge. For example, the number of transport trucks at the land port, Mora, has increased, and the farmers have started doing business by the roadside. Okay, let's introduce the project details. Constructed at a cost of $3.6 billion, the Panama Bridge is 22 meters wide and 6.15 kilometers long, making it the longest spanning the gauge. It comprises a two-level steel truss bridge that supports a four-lane highway on its upper level and a single-track railway on its lower. The bridge doesn't just provide rail and road connections, it also carries vital utilities with telecommunications lines and stainless steel high pressure gas pipes fitted along its length. There are even plans for the bridge to house 400 steel lattice interconnector towards so that it can carry electricity. The bridge's structure is made up of 41 connecting spans of 150 meters in length. These are supported on 24 piers whose foundation were formed of 262 high-strength steel piles. These 3-meter diameter steel tubes are driving up to 100 meters into the earth so that they can support the bridge's massive length and as well as the weight of road and the rail traffic. This steel core means that the piers and their foundations are able to resist every conceivable strain, from liquefaction of the riverbed to impacts from river vessels all the way of earthquakes. Uh, when the Panama Bridge was being tendered, a total of 25 countries participated in the bidding, but many countries voluntarily gave up the bidding due to the extremely difficult project. Many European bridge experts shook their heads and said that building a bridge on sealed ground is an impossible thing. So, how difficult is it to build the Panama Bridge? And makes many countries shrink back. Let me briefly introduce it. Firstly, constructing the Padma Bridge faced the difficulty of ensuring bridge stability. The Padma River is a typical alluvial zone with loose soil. There is low hard rock on the riverbed, and the water flow is very fast. In response to this issue, the project should steel pipe piles as the main piers. Each main pile is composed of 6 steel piles with diameter of 3 meters, a length of 120 meters, and a weight of 150 tons. To ensure that the steel piles are driven into the silt and maintain absolute stability, China Railway Major Bridge Engineering Group Company Limited especially manufacture an ultra-high power hydraulic pile hammer. Creativity used a new piling method, which is setting a solid plug between the concrete and steel pile to form a micro pile cap, so that 130 steel piles are firmly inserted into silt of the river channel. Secondly, it faced the challenges of transporting steel beams. The main bridge structure of the Padma Bridge is a steel truss structure with a total of 41 spans. Each span of steel beam is 150 meters long and weight 3,200 tons. Transporting such heavy steel beams to the piers is not an easy task. The project transferred to independently developed Tianyihao Grand ship from China. It was the most advanced crane ship in China at the time. It not only had a maximum lifting weight of 3,600 tons, but also had self-promoting capability. The addition of Tianyihao ensured that these steel beams could be securely erected at the design positions at one time. Thirdly, it faced the challenges of errors once a large error occurs in a steel beam, as long as 150 meters can result in a slight difference, leads to a huge error. To avoid large errors during welding the steel beams, Chinese builders use the latest high-tech GPS observers to strive zero errors. Finally, it faced the challenges of handling excess sediment. A large amount of sediment is generated by river regulation. To handle this excess sediment, the project partly, in accordance with local conditions, uses the river channel water to transport it to the sludge discharge yard 5 kilometers away through pipelines. Surely, there are many difficulties in the construction process of Panama Bridge. However, there are always more solutions than difficulties. No matter how many difficulties there are, they were all overcome one by one. Boyoun provided 27 sets of segment box girder formwork for the project. We are very happy to be involved in the construction of this project. The Padma Bridge project is a livelihood project under the Belt and the Road initially jointly built by China and Bangladesh. After the completion of the Padma Bridge, the crossing time that originally required 7 or 8 hours of detours or ferries can be shortened to 10 minutes, greatly improving transportation efficiency. It closely connected Dhaka, the capital, with 21 districts in the southwest, making the country's territory connected in a modern economic sense, helping to form a complete the unified domestic market and promoting trade exchanges, industrial transfer, and resource optimization and allocation between regions. The Panama Bridge is one of the important channels connecting China and Southeast Asia's Pan-Asian Railway. It will greatly shorten the trade transportation time and cost between Bangladesh and the neighboring countries and other regions, improve the country's competitiveness in international trade, and have a positive promoting effect on regional and international trade cooperation. Okay, in recent years, against the backdrop of a rapid urbanization, Bangladesh economy has achieved significant growth. However, Due to a weak foundation and a large population, the rapid urbanization has far exceeds the capacity of urban transportation infrastructure, resulting in very low efficiency and overall quality of its transportation system. Dhaka, as the capital and the largest city of Bangladesh, has a resident population of 17 million. With such a large population base, the urban traffic in Dhaka is not only chronically congested, lacking comfort and safety, but also has a poor air quality and serious noise pollution in the traffic environment. To change the above situation, the Bangladesh government has promoted the Dhaka Sustainable Urban Transport Project (BRT) initiative, aiming to provide an efficient, sustainable, environmentally friendly, and safe urban public transportation system along one of the busiest corridors in Dhaka, in order to better achieve the goals of transporting passengers, reducing travel time, and reducing air polluting caused by motor vehicles. The BRT route upgrades from Gazipur to Dhaka Airport in Bangladesh in the first rapid transit system built in Bangladesh. The project starts at the exit of the capital Dhaka International Airport and ends in Gazipur. This project mainly includes the 15.7 kilometer road upgrade and the renovation from Dhaka International Airport to Gazipur, including a bridge, 15 destination overpasses, and 19 BRT stations. In addition, there are 4.5 kilometers of viaducts and the construction of affiliated rapid transit system station and access channels. The funds mainly come from the Asian Development Bank and the French Development Agency. Upgrading and renovation of the original payment. The project is to upgrade and renovate the original payment while ensuring the existing road traffic. The geological condition of the original road base are poor, and engineers have made multiple design adjustments to the road structure. High pressure to ensure smooth traffic. The aspect concrete pavement of this project is 16 kilometers long. Due to the rapid increase in traffic volume, it is necessary to ensure normal traffic during the construction process, and the pressure to ensure smooth traffic is high. In terms of bridge election, the bridge is the a section on all segmental accessed box girders with a maximum single span of 40 meters and a weight of 782.358 tons, a maximum turning radius of 250 meters, a maximum cross slope of 3 degrees, and a maximum longitude slope of 4 degrees. The left line beams of the airport segments are a total of 20 spans of segmental settlement bridge, with a maximum span of 40 meters and a minimum span of 70 meters. There are also the Banner Bridge with two-way 6 lanes and a length of 599 meters. The Line 1 bridge with two-way 4 lines and the length of 721 meters, and so on. A bridge election needs to overcome key and difficult points, such as temporary supports of pier caps, deflection, detection of the main girder with the maximum load of the bridge erecting machine, and settlement monitoring of pier caps. During the bridge construction period, the project builders were not afraid of hardships and overcome many difficulties to ensure the smooth construction and opening of the bridges. Boyoun provided 9 sets of segmental box girder formwork and 4 sets of cantilever form travelers formworks for this project. We are very happy to be involved in the construction of the project and hope that the project will be complete as soon as possible. The Bangladesh BRT project is a livelihood project under the Belt and Road Initiative jointly built by China and Bangladesh. It is also the first rapid transit system project constructed in the city. After entire line is completed and open to traffic, the commuting time from the starting point to the end point of the road will be shortened from the original 3 to 4 hours to 34 to 45 meters. This will not only greatly improve the traffic conditions of the section from the city to Dhaka airport, but also promoting economic change between the northern region of Dhaka and the other regions, and further advance the urbanization process in Dhaka. With the rapid growth of the capital and the increase in traffic on roads and highways, traffic congestions become a major concern. The existing road network was unable to meet the growing traffic demand, and the construction of the third traffic congestion by providing an additional transportation route, improving the traffic circulation between Chatgram and the southwestern district, and bypassing Mariam city to reduce traffic pressure. The main objective of the road widening project are to establish a self-communication system, develop the tourism industry, and improve the socio-economic conditions of the local people through widening some 30 kilometers of the Marine Drive Road and updating of a two-lane 305-meter bridge over Viaduct. The total length of the structure is 1,290 meters, with 400 meters of main bridge, continuously PSA single box girder and the PSA twin box suspended spans in alternate arrangement, and the rest 890 meters of viaduct portion on both ends. Span arrangement of main bridge is 3 multiply 90 meter span, add 2 multiply 25 meters and spans, PSA twin box girder. Span arrangement of viaduct portion is 2 8 multiply 30 meter spans, RCC twin box girder, and RCC twin box cast in steel viaduct, add 2 multiply 25 meters and spans, PSCT girder. Boyoun provided 8 sets of cantilever form travelers formworks for this project. There are great advantages in the cantilever form travelers and the segmental box girder products delivered for the Bangladesh market. Our segmental box girder has the following advantages. Firstly, a lightweight segment and the small sizes, easy to transport and fast in assembly and construction. Secondly, high